Welcome everybody to Pure Virtual C++ 2023. This is our fourth year running. It's a free annual virtual C++ conference for the whole C++ community. And today we have 5 talks for you. We have myself, who's going to start off with C++ compiler errors for humans. Then we're going to have Jim Radigan on address sanitizer with the continue on error mode. Tony Van Eerd is our guest speaker for today, who will be talking about value-oriented programming in C++. Sina McKinja and David Lee will talk about productive cross-platform and game development in Visual Studio. And then Gabriel Dos Reis is going to finish us off with build time reflection with C++ in year 2023. I will have chat open during my talk, so I can see all of your comments. Seeing, hey everyone, feel free to say hi, tell us where you're coming from. And I'm going to kick us off with my session on compiler errors. So for those of you who don't know me, I'm Cy Brand. I am the C++ team at Microsoft's developer advocate. And today I'm going to talk to you about how we can make C++ compiler errors for humans rather than for robots or something else. So to start off with, I wanted to give you a quote from from someone who runs the diagnostics team on Rust. It says, compilers are an error reporting tool with a code generation side gig. Now, you may agree with this, you may not, but the important thing is that error reporting matters. The compilers have to tell us how we can solve our issues and to make us understand what we've done wrong. Otherwise, we can't get anything done. So with that in mind, this is what I'm going to be talking about today. What makes a diagnostic good? How can we judge diagnostics? What criteria can we use? How can we improve them? What do other languages do? People in chat are already talking about Rust and how we can learn from Rust, and I'll talk a little bit about that and see what other people in the industry are doing and how we can learn from them. I'll talk about the developments our team has been making in MSVC on compiler errors. I'm going to talk about some more work we're planning in the future. We're doing some prototyping work at the moment. And then if we have time, we will have some Q&A. Feel free to drop questions in the YouTube comments just while I'm talking. I will keep an eye on them. If you do want to get involved in the conversation, please go over to aka.ms/purevirtualcpp/watch or go to the Visual Studio YouTube channel and you can join in the chat that way. Okay, so what makes a diagnostic good? I asked myself this question, spent a bunch of time thinking about it, and then I thought, well, maybe I could write a paper which talks about what makes a diagnostic good, what are people in academia studying in diagnostics, what are people across the industry doing in production compilers. So I did exactly that. I wrote this paper, Concepts, Error Messages for Humans. This was focused primarily on concepts, but it is applicable more generally to compiler errors. And I sent this to WG21, which is the ISO C++ committee. And you can go read it there if you like. A lot of what I'm talking about today comes from this paper. So you can go to wg21.link/p2429 to read all of the details. It's a fairly lengthy paper. But my idea was I wanted to prompt discussion about what's desirable and feasible for improving the diagnostics output by C++ tooling. So I spent days, weeks reading as much academic literature as I could find on compiler errors, looking at production compilers from across the industry, and seeing what I could glean. But first, on the importance of compiler diagnostics. We had that quote at the start that they're error reporting tools with the code generation side gig. I did find a paper which did empirical analysis into the importance of diagnostics using actual experiments with students. And they noted that programmers do read error messages as much as you might see people on Stack Overflow putting forth a question where the error message tells them exactly what's gone wrong. Programmers do read their error messages. Furthermore, the difficulty of reading these messages is comparable to the difficulty of reading source code. Now, reading C++ source code is a bit more difficult than some other languages, and our error messages are kind of similar. It's generally more difficult to read a C++ compiler error than something coming from many other languages. Difficulty reading error messages significantly predicts task performance, i.e., if you're struggling with your error messages, you're going to struggle to get anything done. And then participants allocated a substantial portion of their total task to reading error messages. People spend a bunch of time reading these things and trying to work out what they've done wrong. So the easier we can make that, the better. So I'll talk about a few of the criteria on which diagnostics can be judged. One is cognitive load. How much does this diagnostic weigh on the mind? And in C++, we're great at this. We get compiler errors like this. If I expand this out, you can see it's basically just a massive template instantiation failure. This is the kind of thing where we run compile, we see this in our terminal output, and we just want to go to sleep or go learn a different language. It's not great. But what are some of the things which we can do to lower cognitive load? I found one paper which specified that we can lower cognitive load by placing the relevant information near the offending code. This could mean printing out some source code, like interspersed with our error. It could mean putting our error directly in the editor with some squiggles or something like that. We can also lower cognitive load by reducing redundancy, trying not to repeat ourselves. We can also lower cognitive load by reducing redundancy, trying not to repeat ourselves. And then finally, we can use multiple modalities to provide feedback, i.e. we can use the editor window, we can use an output window, we can have an error list with different ways of telling the user what has gone wrong, because different people will want to get this information in different ways. The more ways which we can reasonably communicate in an effective manner, the better. Context. We need to know as much about the errors as we can. I read this paper from 1974. People have been studying this stuff for a long time. What the compiler should tell the user. And it says, one of the hardest things to remember in designing error diagnostics is you don't know what the error was. If the compiler knew what was wrong, it would just tell us. Some pieces of information have been found to be inconsistent, but it cannot be said with certainty where the error lies. Maybe in some situations, the compiler can say, hey, maybe this is what you meant, but in general, it's not possible. It also has this piece of advice. The safest strategy is to describe the symptom as clearly as possible before attempting to make any suggestions about the nature of the error. So making a suggestion is all well and good. Hey, maybe you meant a semicolon here. Hey, maybe you meant this function. But in general, it's best to give the user as much information as they need to diagnose the error before then making any suggestions. So say we're using C++ concepts, what would users need to know? It's like an example of how we're thinking about what context to give our users. Well, I think that one, they need to know which constraints failed and why. If you decorate some function with some function template with a constraint, maybe you have multiple constraints. So you need to know which one failed and why it failed, what was found to be the issue. Furthermore, if you have an overload set, you have multiple candidates considered, which ones were considered and why was each candidate discarded. Because if we just look at one of them, well, maybe we didn't even mean to call that overload. We need to look at the entire set and understand why they all failed. Readability. This really annoyed me. I looked at so many papers about compiler errors, and all of them were like, you have to make your error messages readable. And none of them said what that means. None of them said, like, here's how to increase the readability of your error messages, or here's the criteria we're judging readability by. It's very frustrating, but I did find a paper which I think found some good ways to judge this. One said that experts, non-experts, and students assess the readability of messages differently. I.e., if I have some domain knowledge, some specialized domain knowledge, maybe a given error is more readable to me because I can quickly understand, oh, well, there's some complex concepts here, but I already have an understanding of this. Yes, this video is live. I'm seeing your comments. So if I have that domain knowledge, it's more readable to me. However, if I'm a student, if I'm coming at this without that necessary knowledge, then I'm having to parse a lot of complex concepts in order to understand this message. Therefore, it's less readable. Error messages from different languages are perceived to have different levels of readability, which we're very familiar with as C++ programmers. Shorter messages tend to be more readable. If I don't have to parse a huge amount of text on the screen, then it's going to be more clear and understandable to me. Interestingly for me, this one, messages phrased positively tend to be more readable. So trying to avoid negative phrasings actually makes it easier for us to parse our errors. And then messages with more jargon and acronyms tend to be less readable. If I'm writing a C++ program and I see an error with SVNA in it or something, maybe I'm going to know what that means, but someone else will not. So you need to think about who your audience is, who you're writing your errors for. Going back to that positive phrasing, positive tone, I found this delightfully named paper, How a Computer Should Talk to People, from 1982. It says, we learn about and use a computer more effectively when we feel secure and experience success with it. Think about times where you're just having a great day, getting a ton of code out there when it's all working. You feel great about it. If you're just banging your head against error messages all day, not so great. What helps us feel at ease with a computer program or a system? Friendliness. Or put it in a slightly different way from the folks on the Elm team, compilers should be assistants, not adversaries. I really like this quote. This is something to live by. Our compilers should help people. They shouldn't be something which you're constantly fighting against to convince that your code is valid. They should be helping you express what you want. Okay, and then there's a bunch of other ones. Providing examples. If the compiler says, hey, you've got this error, here's something which presents the same error, but is maybe a little bit more cut down, because often there's a lot of context, a lot of code that we're having to deal with. It's not just the pure error itself. Having a small distilled example can really help. Providing solutions and hints, saying, hey, maybe you meant this, but maybe you had a typo in your function call. Maybe you missed a semicolon, this kind of thing. Dynamic interaction, being able to say, I'd like more information about this error, please, and have the compiler delve deeper into the issue. Logical argumentation, this means walking you through what the compiler thought when it was diagnosing your issue, saying, hey, you can't call this function or this overload set because all of these failed, and here's why each of them failed, walking you through the steps that you need to know to say, okay, this is why this error happened. If you don't have that context, that logical argumentation, it can become very difficult. The topic of this is on compiler errors for humans. Diagnosis time. When are we diagnosing errors? Are we doing it while the user is typing? Or are we doing it when they run a build? Are we doing it in CI? There's a bunch of different times where we get back these errors, and thinking about which errors we're producing when can help aid in lowering cognitive load. All right, let's talk about other languages. Talk about Elm. So Elm is a functional language for the web. It's very cool. I've played around with it a bit. It's really, really fun. And this function, well, this program just says that our main function is print 4 to the screen using this text function. However, there's an issue here. Text takes a string, not an integer. We need to convert the integer to a string. So helpfully, Elm diagnoses this for us. Hey, Kenyatta. It says the first argument to text is not what I expect. Note that first person pronoun in there, not what I expect. The compiler kind of talking about itself as a being. Some people like that, some people don't. I think it's kind of fun. It helps to it aids that friendliness aspect, that positive tone. Then it gives us our context. It gives us our code right there, helping lower cognitive load. We don't have to jump around. It says this argument is a number of type number, but text needs the first argument to be a string. So this is logical argumentation, telling us exactly what has gone wrong and why. And then it gives us a hint. As try using string.fromInt to convert it to a string. Very helpful. This is a good error, I think. Very readable, very understandable. Another one from Elm, which I found was this tweet: "Thanks, Elmlang, for the most useful error message I've ever seen." It says, this is a little bit more complex. This type alias is recursive, forming an infinite type. This is like if you are in C++ and you have a struct which you try to contain in itself. Not going to work. So it has a type alias. And it says, when I expand a recursive type alias, it just keeps getting bigger and bigger. So de-aliasing results in an infinitely large type. Try this instead. And in Elm, you can use create a new type instead of using a type alias, and this solves the problem. Then it says, this is kind of a subtle distinction. I recommend the naive fix, but you can often do something a bit nicer. So I'd recommend reading more at this URL. So this is giving you the opportunity to go read more about exactly this issue. It's giving you a suggestion. It's giving you more details about specifically the error which you're looking at. I really like this. Then I want to look at ReasonML. ReasonML is like a resyntaxing of OCaml, basically. This is what their errors used to look like. They did a bunch of refactoring. And it's kind of fine. It says, this expression has some type, but we expected something of a different type because there's an incompatibility. But it's kind of just a blob of text. It's not very easy for me to read. So what they did is they pretty much kept the same content of the errors. They just changed how they're presenting it to the user. So this is their old version, and then the new version looks like this. We found a bug for you. And again, lowering cognitive load by placing that code right next to the error so you can see exactly what it's talking about. Then they thought about how to format this nicely so it's readable. They thought about making sure that everything is well-defined visually, that they're using short blocks, that there's some coloring there to aid in comprehension. It's not like fundamentally different from the error which was presented before, but I think it's many times better, many times more readable, understandable, lower cognitive load. I want to spend a bit of time on this Rust code. So you don't have to understand Rust. I will explain this. Basically, what it's doing is taking an array of 3 integers, 0, 1, 2. It's taking an iterator into it, which is like a range in C++. And then it's trying to intersperse the value 100 between all of these. Then what it's doing is trying to partition this result in place, so not allocating more memory between odd and even. However, there's a couple of issues with this code. One is the partition in place requires bidirectional or double-ended iterator, and intersperse is not one. Furthermore, partition in place, because it's doing it in place, it requires the range to the iterator to be mutable, and intersperse is not mutable. So there's 2 issues there. And ideally, we want to get diagnoses of both. And that's exactly what Rust does. So I've split this up into a few slides. Focusing on that first one. Here we go. The trait-bound intersperse double-ended iterator is not satisfied. Okay. And it shows us exactly where in the code. It even has those little chevrons underneath to point out exactly the function call where this happened, and says the trait double-ended iterator is not implemented for intersperse. And that this is a problem because it's required by a bound and partition in place. So this is pretty readable. It's giving us a lot of context and logical argumentation. Then it diagnoses our next issue. It says, furthermore, we expected this intersperse thing to be an iterator that yields a mutable reference, but it yields a regular reference to an integer. And it says the types differ in mutability at this position. And again, that we expected a mutable reference, but found a regular one. Then, and this is the bit which I find really cool, it gives us more information about our call chain. Says that the method call chain might not have had the expected associated types. So just in case you had expected something to be mutable, like halfway through, it actually walks you through the call chain, not line by line, but expression by expression, telling you what these types are, which I find really, really cool. Like, it tells us that the array is of type an array of 3 integers, that iterator item is a regular reference here, that it remains a regular reference through the call to intersperse, and then through the call to into iter. So this gives us really, really nice logical argumentation. And then finally, it tells us, okay, we're aborting due to our previous 2 errors. Some errors have more detailed explanations, and you can go and find out more about these. So this is giving us that dynamic interaction. Okay, I want to talk about compiler improvements which we have been making in MSVC. Let's look at some code. So I've got some C++ code. I've got a dog and a cat. And of course, I want to be able to pet my dog and my cat. But say I also want to be able to call pet on some other types which are defined elsewhere. Maybe I want to be able to call pet as a non-member function as long as a type has a .pet member function. So I could express this using C++20 concepts like so. We say we have a concept petable. Don't really have to be able to read concepts. This basically says something is petable, some type T is petable so long as, given an object T of this type, you can call t.pet. And then we have a function template down here called pet, which we say we accept anything which is petable, which satisfies this petable constraint. Okay. What happens if we call pet 0? 0 is neither a dog nor a cat, nor does it have a .pet member function. So this is an error. This is what we used to print out. Said pet, none of the 2 overloads could convert the argument types. It could be the cat one, it could be the dog one. It can't be the dog one because you can't convert into dog because there's no relevant constructor. It doesn't tell you what was wrong with the cat one. It doesn't even mention the function template. If we get rid of the cat and dog overloads and just keep that function template, it says that we couldn't call pet. It could be that template version, but the associated constraints are not satisfied. It doesn't tell us what constraint wasn't satisfied. It doesn't tell us why. That's all the information we get. So this is kind of where we were with the old version. With overload resolution, like sometimes it would only list the last candidate. Sometimes it would list all the candidates but not explain why they all failed. Sometimes it would often ignore template candidates like you saw just there. With constraints, we would just say, hey, constraint not satisfied. You wouldn't get any details about why. And additionally, sometimes the line information was correct or missing. So for this, we've been focusing on context and logical argumentation and trying to fix all of these issues. So now if you do this, you get an error like this, which says, couldn't call pet. It could be the cat version, but was not valid. Or it could be the dog version, not valid because of these reasons. And then for the template version, it says, well, the associated constraints aren't satisfied because petable int evaluated to false, because the left.pet must be a class or structure union, but the type is int. So this is giving you all the necessary context you need to solve your issue. One thing to note here is that there's a hierarchy here. There's a structure which isn't necessarily represented in this textual format. It looks something like this, where we have our top level entry is our no overloaded function could convert the argument types. And then we've got our different overloads, the cat, the dog, the template version, and we've got all of the associated reasons those couldn't be called. So there's a structure here which isn't represented just in the text. So what we've gone and done is supported outputting Sarif information. Sarif is a JSON-based format for code analysis errors and compiler errors, and it looks something like this. Don't want to spend too much time on this, but basically we have a message that says, well, no overloaded function could convert the argument types, and then we have a related locations field And that is where we can represent our hierarchical information. So this can now be produced by our compiler. And we're planning to use this for some future work. So the future work, what we would kind of like to see, this is just a mock-up for now, it's something like this, where in your error list, we don't have all that hierarchical information taking up space. We put the top level entry in the error list, and then there's a details field where you can click. So if you see an error and you're like, okay, well, I want to dig deeper into this error, you can click this problem details button, and this will open up all of that hierarchical information so that you can navigate it and click around, see your editor, go to the correct place, all the kinds of stuff which you would expect. And this gives you a way to navigate through your hierarchical errors. Very quickly, I'm going to show you a demo of a prototype we have of this. So this is basically what I had before. I've got my dog and my cat types and my functions. I've expanded this a little bit. Now, Petable concept is, well, it's either has a member pet function or it tells you that there's a default implementation to use. And then these are defined like has member pet says what you can call .pet on it, and default petable says that T has some is petable static bool member. So then what happens if we try and pet a donkey? Well, if I run a build here, then there we go. We get top level entry here. And if I click on this, then it opens up my location here and my related locations. So now I can step through this and I can say, hey, well, it could be the cat version, but I can't convert argument 1 from donkey to cat. Why? Well, because there's no user-defined conversion operator available. Or it could be the template version, but the associated constraints are not satisfied. Okay, why? Well, because petable donkey evaluated to false. Okay, why? Because this is a disjunction, both has member pet donkey and default petable evaluated to false. Okay, why? Because pet is not a member of donkey. And then we can click on this to see the definition of donkey. So this gives you a really nice way to be able to navigate through very complex errors in a way which we simply haven't had before. So that is all I have to show for today. If you have any feedback about this or things you would like to see in these kinds of features, please let me know. You can drop me an email at cybrand@microsoft.com. And this has been C++ compiler errors for humans. Thank you very much. Now we've got, where are we for time? Okay, we have 2 minutes scheduled, and I left a 5-minute leeway, so we've got some time for Q&A. If anyone has any questions, feel free to drop them in the chat, and then we will move on to the next session. This thing, by the way, has been a lifesaver for me. Remind me when to drink water, because otherwise I just forget. And you can, of course, go and look at my paper, which is at p2429, wd21.link/p2429, if you'd like more details. I summarize a lot of the literature which I went through and have a lot of links to academic papers if you'd like to have a look. How are you feeling, Si? I'm feeling good. I'm looking forward to the rest of the sessions. What was the demo about? The demo was showing prototype work, which we've been doing in Visual Studio to surface these hierarchical errors and give you a better way of navigating them, easier way to access our context and logical argumentation and comprehend your messages with less cognitive load. just wait for a few more questions, and then we'll move on to Jim's talk. Jim is going to be talking about address sanitizer and the new continue on error support, which is something I'm very excited about. What sort of timescale are you looking at for preview? So we still have some, I can't share exact timescales, but we still do have time to integrate feedback from all you folks. So if you, for example, looked at my the mock-up here and immediately thought this is terrible for my workflow or something like that, or if you looked at the prototype and saw ways which you thought would work better for the kinds of errors which you're dealing with, we have time to integrate that feedback. So please do let us know if you have any of that. Russ C is saying, thank you for driving the effort to improve error messages. Please don't stop. Yeah, it's not just me. It's also folks at Clang and GCC have been doing a lot of great work in this area as well, and other folks on our team as well. So this is, I think, an industry-wide effort to try and improve the state of compiler errors in C++. In which version of Visual Studio can we test this? So you can't test it right now. Keep your eye out on the Visual Studio C++ blog for when we announce the availability, or also in the release notes for Visual Studio. Okay. Well, I think that we are good for questions, so we can move on to the next talk. So please, everyone, give a welcome to Jim Radigan, who is going to talk about address sanitizer, continue on error. Hey, Jim, how are you doing?
Hi, good morning, everybody. Thanks, Sai. This morning, I was just going to talk a little bit about a new runtime mode that we have for the address sanitizer. It's called continue on error. And what happens is that this essentially gives you a checked build for C++. And the checked builds are defined as finding memory safety errors without any false positives. So I'm going to go through a little story to begin with. I did 2 presentations separated by 2 years about memory safety. And I started out the 2019 talk with the 2018 data. And on the left in the graph, you can see that the number of CVEs had continuously increased. And CVEs are common vulnerabilities and exposures that are basically bugs that have been kept in an international database. After some analysis, out of all the CVEs, 70% are due to memory safety errors. And on the next slide, I'll start to get into what is a memory safety issue. Now, this was 2018 data. So skip ahead to 2021 when in 2022, I did a talk and went back and looked at the previous year's data. And here's the top 25 bugs for memory, not for memory safety, but just for common weakness enumeration. And they each get a score. Now, I was able to clip or snip the top 17, and out of the top 17, 6 are memory safety errors. Now, remember, this is 2 years later. So the yellow ones are memory safety errors: an out of bounds write, an out of bounds read, a use after free, an integer overflow in an effective address calculation for a memory reference that uses that, null pointer dereference. And the last one is when people annotate their code or write their own range checks. So that's 2021. And then I did a talk in 2022. And then things haven't stopped. So if we go to the next piece of data for 2022. This is an award, and I'll show you this. The hackers have an award show every year for the top hacks in all different categories. And the best remote code execution bug in 2022 was awarded to Microsoft, and that was due to a heap buffer overflow. So you can see that we continue to find really scary memory safety errors. So what am I going to talk about? I'm going to show why memory safety is critically important. And hopefully that gets people to use the tools and try to improve this problem, which is systemic. And then I'm going to talk about the new tool that we've got here with a demo, and it's basically going to arm you with something that will allow you to expose all the C++ memory safety errors in your code. And many are hidden. So that last award, for example, that was a heap buffer overflow that had been in the code for 20 years. So to make this more simple, I'm going to tell this as a story between the bad guys and the good guys. So the bad guys are the ones that make memory safety critically important, and I'll show why in a second. And then I'll talk about how the good guys are going to get a well-defined checked build for C++. It'll be a turnkey ship or do not ship. So in other words, when you use the new tool, if your tests pass, but we still log memory safety errors, you shouldn't ship and you shouldn't integrate your code. Full stop. So let's go talk about the bad guys for a second, and hopefully this will motivate you into using the tools that we supply, and the new one especially. So the bad guys have invented new programming paradigms, and people may have heard about return-oriented programming. That's the first one that's been around for a long time. That's ROP, and data-oriented programming, or DOP, block-oriented programming, which is related, and DDM, which is direct data manipulation. These are all started by the bad guys exploiting a memory safety error in your code. And I'm going to show ROP how that works next, and I'll show you that it's Turing complete. So in other words, you can write a program that can match any program functionality by using the stack pointer and the return instruction only. So here I'm going to just start out with a traditional constant store. And what we're going to do at the top is we're going to store val1 into array indexed at val2. And the stack is in yellow, and that's the stack pointer at the bottom. It stays fixed. And then the green box at the bottom are 3 different registers. And then on the left is the machine code that the compiler would generate. So it's just 3 machine instructions. And these instructions are going to execute in a fall-through fashion, and it's going to update at the very, very bottom in the green box, the instruction pointer. So that's 32-bit Intel. So in this example, we'll start out at address 1. So the instruction pointer is loaded with A1. And we execute that instruction, which means load from the stack pointer into EAX. So the stack pointer is pointing at val1. So this is how we get val1 into the machine. We fall through. We're at A2. Now what we're going to do is we're going to load ESP plus 8, which means we're going to get val2 into the machine. We fall through to A3. And when we do that instruction with those register contents, we're going to implement that store. Okay, so that's traditional programming. You're using a fixed stack pointer, and we're manipulating the instruction pointer in the EIP register. So with return-oriented programming, I'm going to show you what they call a gadget. So what I can do is that exact same array store, but I'm only going to use pops and rets. And what's going to happen is on the right-hand side, I'm going to get the stack to have exactly those values because I'm going to exploit a stack buffer overflow. And I'm going to do that before I get to address 1. And that's going to set me up to actually do the following ROP gadget. So as we walk through this, we're going to pop EAX first, which puts val1 into EAX. Then we're going to do the return instruction at A2. Sorry, there's the increment for the stack pointer from the pop. Now we're at A2 and we're going to do the ret. And when we do the ret, we're going to return to whatever the stack pointer points to, which is A3. So that's how we get a fall through. So we're going to pop EBX, which puts val2 into the machine at A3. Now at A4, because we did another fall through, we're going to do a return, and we're going to return to A5. And at address 5, we actually do the store. So right there, what I've done is smash the stack with the right values, like an sprintf or something into a local variable. And then I knew about particular code in your existing program that would allow me to carry out this instruction. So we went from traditional programming to something that is only done with moving the stack pointer, executing returns, doing a few things, moving the stack pointer, executing return. That's return-oriented programming. So now you can stitch these gadgets together, and that's how you can get something that's Turing complete. So you can imagine that this is incredibly powerful, and it's done just using memory safety errors and the existing code in your machine. It all starts with one memory safety error. Wait, what's memory safety, you ask? Well, on MSDN, if you go to MSDN address sanitizer, I put those, I think it's 15 or 17 categories of memory safety error bugs out there. And each one of these URLs, this is what I cut and paste from MSDN, has a link to a specific set of examples. So there's a double free, for example. And then we give a source code example, which is compilable. And then we've integrated this into the IDE. So if you open up that screen dump in a tab, a separate tab, you'll actually be able to see how we've integrated the error into the IDE, which is also in parallel with the command line dumps. Sorry. Well, I'm going to move on. So you get a specifically well-defined notion of memory safety, and this is a great way to understand what is glossed over a lot in the literature. We've very concisely defined this. So in all, what does Microsoft do for security? In other words, where does this all fit, the address sanitizer, relative to the technologies we supply? So I've broken it down to a Venn diagram, and there really are 4 buckets. And if you go top down, you can modify the source. And then if you go a level down, you can actually do static analysis on that or dynamic analysis. And then as a fail-safe for the last, I would say, God, at least 20 years, we've provided secure code generation, which isn't something people talk about a lot. But basically, these 2 areas are runtime, and these are not as familiar as source modifications and static analysis. And so those are the forms of static analysis everybody is familiar with. And those are the existing forms of source modification that you can look up on MSDN. But what I want to bring your attention to today is the secure code generation called GUARD. And that's something that we spent many years introducing to thwart the ROP attacks that I just showed you. Your protection is only as good as what's used. And so what I'm going to show you now is the result of a study that was performed finding out how much of the code on a Microsoft installation for Windows 10 used GUARD. So they downloaded 10 applications from one of the top websites, and only 21 files used GUARD. That's 2%. And then for Windows itself, only 90% of the program files in the Windows system folder used GUARD. Frustrating. So to add to that, you can omit the use of GUARD, which I just showed you, obviously. But then there are a lot of other things that you can just turn off. You can turn off the canaries that we put on the stack for overriding locals. You can turn off safe structured exception handling. You can turn off ASLR, which is the address space linear randomization, where we put things in different spaces randomly. And then you can turn off DEP, which is basically the ability to protect code pages. This should highlight the importance of a tool like ASAN with continue on error. So the war continues today. After 7 years of basically control flow integrity protection, CFI is what they call it in the literature. That is the Microsoft, on Microsoft that maps to GUARD, which I just showed you. So it's been really 7 years in the industry of control flow integrity versus ROP attacks. And the bad guys have not rested on their laurels. I found a really great paper here, Roper, which is a blazing fast multi-threaded ROP gadget finder. That's 2018. And that's in use pretty heavily today. So the bad guys have also moved on from ROP attacks, which is trying to exploit control flow, to data-oriented attacks. Sorry. So here we have what data-oriented attacks do. They manipulate non-control data, like they'll change variables and pointers, which don't contain target addresses. They'll change benign behavior and without violating control flow. So a simple DDM, direct data manipulation example, would be to flip a bit in a variable that's used in an if then else. So if I, at the right time, flip the bit in if X is true and invert it to what was expected, I can change the behavior of your program dramatically just by flipping that one bit through a memory safety error. So these are how they're related. I didn't have enough time. Usually I go into them. But data-oriented programming and block-oriented programming are sophisticated attacks that take chunks of your existing code to carry out actions that you can actually program in a separate language. And DDM is what direct data manipulation I just talked about by flipping a bit. And so DOP and BOP are actually used by a compiler called Sploit. So this is actually the Sploit language. You can program something to create your own shell here. And it'll do it by going out and looking at a binary, whatever binary you feed into it, and it'll get blocks of code to actually carry out exactly this program. So, real world examples. Here's the Windows Movie Maker. This is a famous exploit that happened before. CV size is 4470. We allocate a buffer that's 4470 bytes. That accidentally changes it to 4496. And then down here we have a heap buffer overflow, and you're gone. This is SQL Slammer. This hit the internet a while ago, though. So this is an instance of a read name from a socket. And then down here, we have a stack buffer overflow because of this sprintf. And what happens here is that the return address is corrupted. And so they've got the bad guys starting an ROP attack with an open named socket. So how bad is it really? So NIST, the National Institute of Standards and Technology from the US Department of Commerce, has put out guidelines on minimal standards. And when the government gets involved, it's very scary. You've heard the phrase, "We're from the government, we're here to help." Well, they're here to help now. So the bad guys are using those 4 forms of abstract programming against us. So what about the good guys? That's us. So delivering C++ requires both static analysis and dynamic analysis. End of story. You've got to do both. So when I talked about static analysis and dynamic analysis, I'm going to relate it back to our Venn diagram. And everyone's familiar with /analyze. And I think people are beginning to get more familiar with the address sanitizer. So what I want to do is show a little demo that shows the difference between static and dynamic analysis to make this tangible. In the program on the right, what you can see down at the bottom in main, the first line, what we're going to do is we're going to allocate a derived object, which is larger than the base object, but we're going to point to it through a typed pointer, which is the base. That's polymorphism 101. But then what happens is we're going to delete B. And when we delete B, where the red arrow is, we're going to delete the base. In other words, we're going to delete something that's smaller than the space that we allocated, and you're going to have a leak. So if we use static analysis that's in the IDE, then what happens is you'll get 4 errors or 4 warnings. The default constructor should not throw. Work with delete can be declared no except. Down here, we should not use an explicit smart pointer reassignment. And then the real core error here, it says do not delete a raw pointer that is not the owner. Now, if I go to the address sanitizer and just run this, this is what you'll get on the command line. It'll tell you that there's a new and delete type mismatch. The allocation was 12 bytes. The delete was of a 1-byte object. It'll give you the call stack for where things were allocated, and it'll give you the call stack. Oh, wait, this is where it was deleted. That's where the error was detected. And then here, it'll tell you where the new occurred for that error. And then if you'll notice down here, what it does is it aborts. So in the old model, it's one and done. Upon hitting the first error, it'll kill your process, which a lot of people thought was pretty draconian. Nope, sorry. Okay, so that showed the difference between static and dynamic analysis. So what you can see with static analysis that takes place at compile time, the language itself limits what you can do. So there's a circle or a cycle, abstract cycle, that where type propagation will thwart alias analysis, and alias analysis can thwart type propagation. So if I don't know the type of the pointer P, when I get to the call of foo, I can't do the alias analysis, and I can't really even type propagate across that. So for example, star Q, if they're P and Q are global pointers, I have no idea in this program what they're pointing to, and I have to assume worst case. So dynamic analysis takes place at runtime. It breaks that cycle that I just showed you. And basically, you just need good code coverage. And the other win, too, is that a dynamic analysis like the address sanitizer, all of your third-party libraries are in there affecting the behavior as well. So you see exactly what's going to be going on as long as you've got good code coverage. But I run over 3 million tests daily. Why do I need this? Well, here's an example of a program that we call secure by coincidence. There's the red arrow should be, or the red loop exit condition for that for loop is off by 1. It shouldn't be less than or equal to, it should be less than. And so what happens then is you get a buffer overflow in the abstract. But in reality, this program will run almost all the time. The system allocates the storage into local, but malloc has what we call slop in it. We're going to actually allocate a chunk of memory that's cache word aligned. So it might actually allocate something that's 0 mod 32 padded. And so invariably, local is going to always have one extra cache line in it. And that's what we call the slop. So this program is secure by coincidence, and the memory safety error, or the buffer overflow, is hidden. You'll never see it. So dynamic analysis is a simple recompile. The address sanitizer will compile in all the necessary runtime checks. It'll link to asan.lib, and it'll diagnose all your errors at runtime. So the problem with the, as I showed you before, is the existing sanitizer is a one and done. It'll do a great job diagnosing the first error it hits, but then it will abort your process. So one and done is a problem. So a top 5 ISV, they build 36 hours. They have 200,000 plus tests and 100 distributed test machines. And the first day you try to deploy the address sanitizer, you basically blow up a super large test lab, and it is a giant undefinable triage effort. So it's not practical to do the one and done for large code bases. And there's a lot of wins to do something different other than avoiding this negative. So what I'm going to do is show you another demo. And here we go. And we are in Pavre. So Pavre is a ray tracer, And the first thing it does is it hits a new delete type mismatch and it aborts. Pavre is a really large program, by the way. So normally you would see the one error and you think, oh, I'm almost done. You go home, no problem. But if I set ASAN options equals continue on error equals 1, and I run the same program, what's going to happen is we're not going to stop on the first error. So in this particular case, what you can see is that we have found 14 unique memory safety errors. And we define unique based on call stacks. So in other words, call stacks are paths. So there are 14 different ways that this program will leak, 14 different paths. The new address sanitizer with continue on error provides a checked build. You can actually compile this way and just run all of your normal testing because it's not going to die on the first error and it won't interfere with the output of whatever's being produced by your program. And you'll get well-defined errors. They'll all be memory safety errors. And the compiler will insert all the necessary assertions. So this is well-defined. It's not like you have to manually annotate your code in any way, shape, or form. So in essence, it's a turnkey system. You know, you just compile your programs with the address sanitizer, and then you set an environment variable, and you go. The interface is really not that complex. We give you two choices. You go to the command line through stood out or stood error. Or if you really don't want to interfere with any output whatsoever, all of the memory safety error information can go to your log file of choice. That's it. Hopefully everybody understands that and the importance of it. And I look forward to answering any questions if we're still there.
Yeah, thanks very much for the great talk, Jim. If folks have any questions, please drop them in the chat. If you're watching somewhere which is not the Visual Studio YouTube, then you can head over there and you should be able to see the chat right underneath the window. As a question of my own is, what would you urge people to do right now for making their builds safer?
Well, the easiest thing to do is use 17.6 and start trying to compile it this way. It's just that simple. And it becomes a pass-fail gate. All you got to do is run it this way. And if it fails by passing your tests that you normally do day to day, but actually suddenly logs memory safety errors, you shouldn't ship and you shouldn't integrate into the next branch.
Yeah, that makes sense. Okay, we got a question from John who says, can you tell us the difference between continue on error equals 1 versus 2?
Yeah, sure. What that means is that that's this slide. The continue on error 1 is stood out, the stood out stream, standard output, and 2 is standard error. We map 1 and 2 to those.
Just like on Unix. And then another question is, would you recommend enabling ASAN for debug configurations as well as release? Should there be a difference?
There will be a difference, and I would enable them for the debug releases, because what happens is so when you run debug, the optimizer is not on, although to be sure, we went through great pains to make this work with all the myriad optimizers flags. But the interesting thing is when you optimize, you eliminate memory references. And so what can happen then is it'll hide or mask what are memory safety errors because things only live in registers, or you do things like dead code elimination. So I'd start with the debug builds or, O2 check builds, which that's a term that we use, I'm sorry, at Microsoft quite a bit, which check builds are, we turn on some optimizations and we have assertions in there. And it's like 2/3 of the way towards production code, but it finds a lot of errors. And this is a way of giving you a check build on steroids.
Yeah. Any other questions for Jim? We are 5 minutes until the next session is scheduled, so we've still got a little bit of time if anyone has any questions. And Jim, could you drop a link to me or in the chat for the best place for folks to go if they want to find out more about this?
Sure. The blog is going live today.
Perfect.
Can you see me and the slides that are on the screen?
We can see you. We can get their slides are there now.
Okay.
John's also asking, is the continuous error support in production today?
Yeah, it's in 17.6. I'm in the middle of, when I get out of here, we are building all of Office with this right now. And I'm also working with a team in France, a big ISV, and we're trying to get their entire code base covered with this. And Office we're building on, just to give you an idea of the size, when we build Office, the machine I'm using right now is a 32-core Threadripper. It's got 256 gigabytes of memory, and it has 10 terabytes of SSD. And I think it runs for 30 hours.
Wow.
So we're really trying to scale this up for production use. And that's why in 17.8, we're going to move it out of experimental into full production, full guarantees. So we're really looking for feedback on this. And we plan to add the leak sanitizer to this as well. In an internal demo, I add the leak sanitizer by adding one more flag here. And then, of course, we're going to optimize so that when you compile this way, you won't take the performance hit from all the assertions.
Yeah. All right. I think we got last question here from FPPT1, who says, is ASAN built in to be easy to use graphically within Visual Studio?
Oh, yeah. So in my failed attempt to pop the screen, if you go here to the website where I drilled into the double free, for example, and you open this in a new window, you'll see on the left-hand side is the command line output. And then over here for the double free, we've integrated the address sanitizer error reporting directly into the IDE. So if you start out with dev-env/debugexe and you just run this thing, it'll actually pop that up with the source code for you.
Great. And then Ken's asking, is ASAN new functionality? For which, yes, we can say that it's been around a while, but the Windows support is last few years, and this is brand new stuff that we're talking about today.
Yeah, the address sanitizer has been around, Google's responsible for starting it. And that's, I think, circa 2012, really, was when they first did the Usenix conference. What's been difficult in bringing this up on the Windows platform, though, is we have a tremendous amount of legacy and the interop for all the different languages. And then one other thing to note is that Continue on Air is first being brought up on the Windows platform. It doesn't exist anywhere else. We're going to open source it and move it upstream, but there was a lot of complexity. So what's neat about this is that if you hit a memory safety error, we're going to continue executing, so that bad mutating write will actually do its thing. And we found that was actually modifying metadata in the ASAN runtime, and the ASAN runtime would blow up. So we had to move the metadata around, make sure it was safe, and it was a pretty involved thing. And so it's going to be slow going to get this upstreamed and accepted by the community.
Great. Well, thank you so much for your time. There's maybe one more question in chat, but I can get that answered over text for you because we are on time for the next session now. So thanks very much, Jim. Great to have you on board. Okay, great. We're going to move on to the next session now. Tony Van Eerd is going to be telling us about value-oriented programming. Hey, Tony, welcome.
Hi, Sai. Always wanted to say that. Do you want to talk about purple dragons? I bet you do. All right. I'm Tony Van Eerd. I work at Christie Digital. I want to talk about objects and values, which is a very simple topic, and because it's so simple, such a simple topic, it takes hours and hours to explain, because the simplest concepts are always the hardest to explain. So I'm not going to try to explain it all. I'm just going to do a crash course. Right? There's too much to explain everything, but we'll do a little crash course. I'm on the C++ committee. Some of my papers worked on things like optional invariant, some little bits of concepts. Like to complain about naming a lot. The yellow papers are successful papers I've written. But if you're only going to read one paper, read the two pink ones. Those are my favorite. And my other, I like to claim to fame here is Herb Sutter said my code is righteous. Let's not worry about what the context was. Let's just assume he meant all my code, ever, future, whatever. But what I do is projection mapping, right? So, which is working with projectors, projecting something that basically texture mapping objects in the real world, not inside the computer. So that is not really a purple dragon. I can't even see myself. How's my video? All right, there, yep. It's a gray model of, it's not really a dragon either, it's a model. And it's not even on the table right now. But that is a table in the picture, so it is 1 out of 3 is true. It's a video of a presentation of a picture of a table, and then it's a fake dragon, and the dragon's not purple. But let's pretend that it's a purple dragon, and you can see that it's on the table. So the word the is taking up doing a lot of work there. It's not a dragon, not just any dragon, it's the purple dragon, it's on the table. We could spend all our time talking about the word the, but Bertrand Russell did that over 100 years ago. Go read all he's got chapters on the word the and another chapter on the word a. So we can leave that to Bertrand Russell. How about is on, and purple dragon is on the table. We basically have 3 things there: values like purple, objects like the dragon and the table, and relations between them like is on. And in philosophy, people like to, should I have warned people philosophy is going to show up? Sorry. They usually talk about properties or attributes instead of, in programming, we like to call them values. And philosophers often want to eliminate at least one of these categories, because wouldn't the world be simpler if you only had two categories or one category? So you can kind of say like all properties, like purple is not a property, it's just an object, but it's an abstract object. It's the color purple, the abstraction of purple. And then you could say the dragon being purple isn't an attribute, it's just a relation between the dragon and purple. Or you can make properties into relations. You can try making any one of these. I had a prof who tried to make he made everything relations. He got rid of the other two. People usually keep objects or values. He just got rid of relations, or got rid of everything and only kept relations. And if you start out with the identity relation, the relates to self, which is literally the relation relates to the relation. So because it needs nothing else, it can just pop itself into existence. And then from there, you can build the whole universe, right? Because then you just make more and more relations that relate to other relations, and you get a universe out of that. At least one prof thought so. So we could concentrate on relations like is on, and go down that route. But there's actually a more modern philosopher, Sean Parent. He's talked about relations recently. So we can let him handle that part. We'll talk a bit about relations, but we'll let Sean do most of that part. So that leaves us with values and objects. And just to ease your fears that it's all going to be philosophy, there's some code, right? So it's pretty much, that's surprisingly close to how philosophers and programmers think the same of, a dragon is an object, like a class. It has some properties, some attributes or values like color. Now, of course, color could also be a class. So then you might think, is color also an object, or is color somehow a different type of class? Then it's very value-ish. And that's the part we want to try to figure out, when are classes more object-y and when are they more value-y? And what do we mean by values and objects? And because this is a crash course, I'm just going to throw out some examples so you can get a feel for the idea. Because I'm kind of using object not necessarily the way it's always used, not the way the standard use it, because the standard, every blob of memory is almost an object. Every variable is an object. Object-oriented programming kind of tends to mean something different than the standard. So, a button or a projector. Projectors, I work with projectors. They're big physical objects. The ones we have are like the size of a refrigerator. They're objects. They're literally, real world objects. And then we will, in our code base, we have a C++ object that represents that projector. A button is almost a physical object, like a UI button. It might as well be physical. You click on them and tap on your phone or whatever. Slides in a slideshow, kind of object-y. But something like an int is the canonical example of a value, or a string, even though it's a class, or a point class that might have X, Y, Z in it. They're objects in that sense, but we tend to treat them like values, right? Or color, color is a value. So that's kind of what I mean. And objects tend to be not copyable. I would love to be able to make a new projector just by copying it in memory on my computer, but no, they're very expensive things. You come out of a real physical factory. If you passed a button by value to a function, would you want two buttons to show up in your UI? Right? I don't think buttons usually are passed by value. A lot of things that you don't want to be copying. It's objects. And typically, if you have objects in a hierarchy, in an object-oriented hierarchy, you're not making copies. Sometimes, but not usually. Whereas values tend to be copyable or movable as an optimization of copyable, basically, typically. Like, again, like int, it is the de facto standard value. And objects are changeable, right? Observable, they have lifetime. You know, the button is checked, now it's not checked. The dragon was purple. I can make the dragon blue, I can make the dragon red. The dragon changes over time. Whereas values, in some sense, are immutable, right? The number 17 is, going back to the, Bertrand Russell, is the number 17. It's not a number 17, it's the number 17, because it's always the number 17. You can count on it. It's a number, you can count on it. So it's always forever 17, never changes, right? Your variable, your int, can have a new value in it, but you tend not to care about that. You care about the value inside the int, and the value itself is immutable thing, in the conceptually immutable thing. The number 17 is immutable. And then I like to call them both timeless and ephemeral. Timeless in the sense that 17 is always 17 forever, but ephemeral in that your values in your program tend to come and go, right? And an integer comes into a function and it leaves, and you're not, it's not necessarily a state you're tracking everywhere. It's just a temporary value more often. If you take an int and make it a global variable, then, well, okay, now things are different, but typically they're very ephemeral. And objects are the ones that get to have relationships, right? The dragon is on the table, like that. And buttons are, the child of a window. And these are dynamic relationships that can change. I can take the dragon off the table. And, the button can move around and not be on the window anymore, and things like that. Values also have relations, but that's more mathematical, and it's static relations. Like 17 is less than 23, always. Once again, you can count on it. But we can do other things that with values, like make pure functions that, or like Stepanov likes to call them regular functions, that take values and return answers, and we tend to use functions more than relations on values. And of course, if you're thinking languages, Java is the classic example of an object-oriented language. There's many others. I like to think that C++ is a value-oriented language. And, there's a million other functional languages out there that are more value-oriented. But C++ is multi-paradigm. It can be an object-oriented language, but it's in some sense fundamentally value-oriented. You get a default copy constructor when you make a class. It's like, yeah, of course you want to copy things. Of course you want to, like, C++ tries to, by default, make your class work like int. If you don't do things to make it not that way, it's going to work like int and be very value semantic. And similar, the STL, because of Stepanov, is very value semantic. Vector, even though it holds a bunch of values and feels like a big object or something, vector acts semantically like a value. You can copy it around. Equal on a vector checks the value of the elements of the vector, right? Are the values held by this, everything held by the vector is the value of the vector, and equal checks that, right? And in object-oriented programming and stuff like that, it's like, and I once had to teach a bunch of Java programmers, refresh their C++, and they were all worried about pointers and tracking memory and all that kind of stuff. And I found it really odd because, there's pointers all over Java. There's called references, and sure, you don't have to worry about the lifetime, but you still have to worry about where they're going and who's got who's sharing them and all the relationships between things. So, but they were all like, oh no, pointers. And then over here in the value land in C++, you can be, oh, no pointers. Like you just, if you treat your, vector holds a pointer inside of it, you never have to see it. You can just treat it like a value. All right, I don't know how well you guys are hearing the audio, but he obviously said copy or copy not. There is no shallow. Kind of as an example, that's just what as I was mentioning about vector there, and versus the oh no pointers, right? When you have a class, whether it's a vector or some other class where you have a pointer inside your class. If you make a copy of that class, by default, you're going to get this, and you're going to have to worry about what to do with the pointers. And as we all know, you probably want to do this and make your two objects distinct from each other and not share the data because you don't want shallow copy. There is copy or copy not. There is no shallow. Trust me on that one. And, Master Yoda said that, and Master Stepanov pretty much said the same thing. This is the definition of regular, of like a regular type. A regular type is basically one that acts like int. When you assign it or make a copy, the copies are equal. The important one there is that if you make A and B equal to C and all three are equal, and then you change A, well, B and C are still equal, but A is no longer B because you changed A and it's distinct from B. There's no parts being shared. It's separate. And that's just an important part of being a value, is being a distinct value. One value, 17 and 23 aren't going to mess with each other. All right, where do I go? Oh yeah. So back to this. The real difference on the left from the right is that objects have identity, right? It's like this object, this dragon, the dragon right here. Whereas values, you tend not to care about the identity. Sure, you have variables, but an int that's flowing through a function, you care about the value inside the int. You don't care about the variable. If you take an int and you make it a global variable, suddenly it has an identity, right? Its address is important. And it's the identity that allows, by having identity, you allow yourself to have, it changes over time because it has an identity and it's observable. You can be like, I'm talking about this global integer, or I'm talking about this object that has an identity. And you can have relationships. There's like this object and that object. If I can't identify it, it's hard to keep relationships between them. And the real, philosophical way of thinking about this is the good old ship of Theseus. Anyone? Everyone knows ship of Theseus. It is basically, this is it's not just everyone uses it as a logic problem or a paradox or whatever, but it really was a ship that they were keeping intact and restoring constantly, right? If a piece of the ship needed to be replaced, it was replaced, and then the next piece was replaced, and the next piece was replaced, to the point of there's no original ship left. It's all been replaced. And then the question is it still the same ship, right? And to a certain extent, I think this is objects versus values, right? It's like, do I care if it's the same ship? I just care about the value of the ship. I just need something that floats or something. Or I need to know the value of the ship, or I need the identity of the ship because Cy and I have decided that we're going to meet on the ship of Theseus. So like We need to meet at the same ship because we want that relation with I am on that ship kind of thing. And the other question about the ship of Theseus is, if we take all the wood that we replaced and build another ship out of it, which one's the ship of Theseus? The one that we kind of labeled the ship of Theseus, we've given it that identity and we've tracked it, or the one that we've used the original wood? It always gets the old wood, so it's kind of the original ship. And then the other question is, do we care, or do we only care about the value of the ship? And it, like all questions in C++, it depends. And that leads to this. There's a good talk by Rich Hickey called The Value of Values. You should watch it. Not right now, but you should go watch it. And he calls it place-oriented programming, PLOP, because, the identity in object-oriented programming is the address, right? The reference, the pointer, the address of the object. And it's like, we're talking about the dragon at this memory address, right? Place forms the identity. And I think he kind of purposely gave it the name plop because it doesn't sound great. But that's basically what most of our coding is like. It's place-oriented programming where we're tracking the state of the world in a place in memory, which, that is what programming is kind of about. That's what computers do. But let's see what some other philosopher had to say about it. Right? He said, state leads to suffering, right? If you get the extended cut of Star Wars, you see the full quote. State leads to objects, objects lead to references, references lead to sharing, sharing leads to entanglement, entanglement leads to suffering, right? So, state is hard to avoid. That's what computers do, but it's how we try to manage that state. As soon as you start having objects and relationships between the objects, you have to remember, like, Jedis weren't supposed to have relationships. Anakin, Padme, get entanglement and leads to suffering. It's a path to the dark side. Similarly, another philosopher, Sean Parent, likes to talk about incidental data structures. And imagine you have this. There's a billion examples of this, but say you just have like a contact app on your phone, right? So you've got a class called contact, and maybe it has points to another object called location, and they're, maybe you would do this as just a member object, but maybe it's a separate class and you have a pointer to it for some reason. And then that forms a data structure, right? And then you can have another contact, and it's another instance of your data structure. But if you ever end up doing a shallow copy, or for some reason these two people share an address, the two contacts live at the same location, you might end up sharing a location. And whenever you have pointers crossing between objects like this, this is not two data structures. This is one data structure, right? Sean likes to call it an incidental data structure. It's not the data structure you thought you were making, but it's in your code, and you really see this everywhere. Almost every use of shared pointer, you're forming an incidental data structure. You might think, oh, I've got a window and it's got a pointer to a camera or a projector or whatever, and these are separate objects. But as soon as you are pointing to each other, you're building a data structure, and it's probably not a well-defined data structure. You've just got random bits of code that has to know what the rules are. Oh, do I own this object? Can I do this? Can I move it right now? Can I do this to it right now? There's a data structure hiding in there, but you've spread it out throughout your code. Yeah, I really think almost all code looks like this. Everyone's code base is full of incidental data structures. And, Yoda's trying to convince us not to entangle it, and Palpatine's just going the other way. I'm pretty sure that's what he says, right? I am the state. Yeah, I think that's it. So how, what are we going to do about this entanglement? If we go back to, objects versus values, maybe we should talk a little bit about math and regular functions and stuff. So I did a talk earlier this year and last year on the same idea of value-oriented programming, but more focused on functions. And by the way, I like to call it value-oriented programming. It's going to catch on. Like I like to think I'm the first person who used this term, but I found a paper just the other day from 1981 that used the term value-oriented programming. It's a good paper, actually. You should read it. Not right now. But some people call it just value semantics or whatever, but it's very much values, when can we be more value-like instead of object-like? So value-oriented programming. Here's some functions, right? Kind of when you think of functions, you think of one of these mental models. And you might even wonder, like, what's the difference between these two models? If you don't know Dr. Seuss, you might not recognize the one on the left. It's the putting stars on your sneetches. So the one on the left takes an input and modifies the input and produces an output. The output is the input, and it's just modified something. It probably took something in as a pointer and modified it directly. Whereas the mathematical world, you might take 17 as an input and produce 23 as an output, but you didn't change 17 or 23, right? And this is my favorite quote nowadays. It's not an exact quote, actually. I've kind of paraphrased it, but it's a good book by Eric Norman called Grokking Simplicity. You should read it, not right now. And one of the fundamental concepts is separating calculating from doing. And what do I even mean by that? So let me kind of explain that. If we are going to put stars on sneetches, because, who wouldn't want to do that? You can think of the function that does this. You notice it takes a sneetch by reference, non-const, returns void. So it's very much modifying its input directly. I think functions that return void are something to be worried about. Not always, but often. But anyhow, a star on function would probably measure the sneetch, find the belly, calculate star positions, and then apply the stars to the sneetch, right? Everyone knows how to put stars on sneetches, I assume. And three of those things are calculating, and only one of those is doing something. It's only one is affecting the state of your program. The first three can be done in a function that doesn't change anything. It takes values and returns an answer. In fact, you probably wouldn't take the whole sneetch. You would probably take some representation of the geometry of the sneetch. And you either take that as a const ref or whatever, right? It's like you're basically treating the geometry as a value. You're calculating a star position. And then, sure, apply stars is a valid void function that changes the sneetch directly. But you've separated your code into, let's say 3/4 of it is now calculating, and only one part does as it probably turns out, the calculate the star position is probably a lot harder than applying the star, right? It's usually applying the star is write your values into your document or something like that. And you can imagine that one of these functions is a lot easier to test, right? Calculating star position, you can test in isolation. You can understand it in isolation. You don't have to understand the whole program. Actually applying stars, modifying the sneetch, worrying about, what the sneetch being an object, what relations are going on between the sneetches and all this kind of stuff. So it would be nice to have more pure functions, right? Same input gives the same output, and no side effects. Minimize your side effects. That's the doing part, and separate calculating from doing. And all the calculating part is basically functional, is basically value semantics and local reasoning. You can, it's a lot easier to think about a function that doesn't touch anything outside its inputs. And you don't have to understand the whole program if you don't have to worry about all the entanglements. So I have one question I know people are supposed to ask me questions, but instead I'm going to ask questions. The Queen of Clubs. Is the Queen of Clubs an object or a value? So my kids are always like, why don't you ever write a game, right? I'm a programmer. I don't really write code at home. And they're like, why don't you write a game? So I started writing a card game. And of course it was like command line card game. And of course I spent all my time writing the library that's going to be like, I could write with this library, I could write any card game. And I'm like working on the class for card. And it's pretty simple. It's got a rank, a suit, and then it's like, oh, should it have a copy constructor? Like, should you be able to copy the Queen of Clubs? Is the Queen of Clubs the Queen of Clubs? Is the Queen of Clubs an object, or is it just about like the rank of the Queen is the rank and the suit are just two ints or something, or two enums. They feel very value-ish to me, but the Queen of Clubs, is it a value? Is it an object? Is it sometimes both? Should I have the card object class and the card value class somehow? And then what's the relation to is the Queen of Clubs a object because it's in your hand and then it's played on the table and then it's moved around? And the real worry was like, I don't want to suddenly have two Queen of Clubs in my game accidentally. That's why I didn't want to copy. Now we have move semantics that could also help here, so that just make it move only. But I was stuck. This is why I didn't finish the game. I was like, I really should figure out if this is an object or a value. And then someone spilled water on my laptop and I lost it all. So I'm getting right near the end here. Here's my thoughts on, I'm not even sure what this means, but something trying to, objects aren't everything. So Cy or anyone else, do you have any questions about the purple dragon that's on the table, which is really not purple nor a dragon nor on the table?
Well, thanks very much for that talk. And if folks have any questions, please drop them in the chat on the Visual Studio YouTube channel. We've got a couple of minutes until our next session. And I would very highly recommend going and watching the Tony's talk, which you mentioned on calling functions. I find myself now thinking about that when I'm writing code and thinking, which function would I like to exist at this point while I'm writing my program? And then I just
write the functions you want to see in the world. Write the functions you want to see in the world.
It's a great talk. Any questions for Tony?
I have a feeling I went fast. Sorry if I went fast.
Oh no, you're actually about perfect.
So classically, also, I never know how long my talks are going to be because I don't time them.
Yeah, I remember I gave a talk at ACCU once on explaining Hello World in C++, and we overran our 90-minute time slot because Hello World is just too complicated for 90 minutes.
Definitely.
All right, well, K-Music says it's superbly explained. Milos says, how do you feel about functional programming, Tony?
Oh, I mean, I kind of love it. I just, it's not going to, for some reason, it doesn't it's not taking off completely. It seems like we're not going to write I mean, it's out there. People are doing it. People are writing real software with it, but it's not the predominant way of writing code. And there's probably reasons for that. So all I'm trying to do is make my code functional where it can be, right? Fundamentally, I think, I use projectors and cameras, right? Fundamentally, they are objects. I think objects is correct for them. And I use different types of cameras, different types of projectors. So they are fully polymorphic, the whole thing. Now you can do polymorphism in value-ish ways, like using variant and things like that. But these are just classic, object-oriented things. But it's really that idea of splitting off. And I see it, you see it all the time where I have giant functions and it does a whole bunch of work. And the last line of the function is, okay, now set the answer into the member variable. And I was like, wow, all this other stuff was just calculating stuff. And that could have been split off. And then, you don't, there's secondary problems going on here of I like to say classes are made of Velcro, right? You got a class like camera class that just keeps getting added more camera stuff to it. And you put also, I'm not a big fan of member functions. You keep adding more and more to that class because, it's camera stuff. And so much of it could have been split off to just be a free function that just, sure, the camera takes an image, but all the image processing is in a free function or things like that, like auto exposure and things like that can all be separated off and be very functional. And then you do the objecty stuff for the objects. Val is a experimental language going on right now that's trying to get the best of both worlds. They allow modification of objects. Like functional programming, you never modify anything, right? Everything's immutable. Val is in-place modification, but still very functional, hand wavy.
Yep.
And, you can either try to find a language that does that or just, I like C++, I'll just use, I think C++ is a functional language trying to get out of, whatever. There's that saying, it's a small language hiding inside the big language. There's a small functional language hiding inside of C++.
For sure, yeah. All right, well, thank you so much for joining us, Tony. And we'll head over to the next talk. All right, so next up we have David and Sinem, who are going to be telling us about game development and cross-platform development in Visual Studio. Take it away.
Hi, everyone. Welcome to Pure Virtual C++. My name is David Lee, and I'm the Game Dev Product Manager at Visual Studio.
And I'm Sinem Akunja, and I am the cross-platform and CMake Product Manager for C++ in Visual Studio and VS Code.
So we've got quite a lot in store for you. Whether you're a game developer or not, we will show you how Visual Studio is the fastest yet. Of course, over the past years, we have been working hard on building first-class Unreal integrations into Visual Studio so you can spend more time in Visual Studio without switching back and forth to the Unreal Editor. Sinem will cover some cross-platform tools that allows you to target Mac or Linux. And of course, we'll showcase a variety of our latest productivity enhancements. But before we begin, I'd like to thank you to everyone who gave us feedback on social media and developer community. A lot of your suggestions is what made this available today. So let's get started with performance. You can open Visual Studio faster, get to your code, and of course, it's more responsive and spend less time loading. As you can see here, we benchmarked Visual Studio using a real-world AAA Unreal Engine 5 game, which is a large code base. And for several scenarios, there is a code and a warm distinction. Code just means that you're opening up your project for the very first time. Warm means you have opened your project previously Visual Studio has done indexing and all the other background activities. You can see here, we made significant improvements in reducing the time it takes to parse your C++ solution. It used to take almost 280 seconds, but now it's around 90 seconds. That is a 3.2x faster improvement. Of course, we have continued to improve our solution load scenarios. Here you can see we also made great improvements for the solution close scenario. What used to take 4 seconds to close for the first time takes only 2 seconds. Similarly, for the warm scenarios, where both scenarios are now about 2 times as fast. We have also focused on areas such as C++ colorization and the speed of searching C++ code. These scenarios are just a fraction of what the team is working on. And of course, it only counts for improvements since VS 2022, 17.2, which is the last we've taught at Pure Virtual. And of course, Visual Studio 2022 will still be focused on performance. So next year, you'll see even more performance improvements for your large code base or Unreal Engine games. Some of the productivity tools that has arrived in the past year are meant for game developers. This one specifically is meant for game developers who work with shaders. We partner with the extension HLSL Tools, which is a very popular shader editing extension made by Tim Jones. As you can see here, you can open your shader file and be presented with full IntelliSense, as well as colorization. You can navigate throughout your shader files with go-to definition. And of course, this not only works for HLSL, but also for Unreal's shader files like USH or USF. And of course, Unreal Engine integrations, something that a lot of Unreal developers have been waiting for. We heard a lot from both our community and our first-party studios about how they want to do more in Visual Studio without having to switch back and forth between the Unreal Editor and Visual Studio, thus creating mental strain, and because you have to mentally task switch every time. Let me show you how an Unreal developer can use Visual Studio today to enhance your Unreal Engine development. Starting with Unreal blueprint references. Let's say your gameplay artist or level designer handed you a bunch of blueprints. In Visual Studio, you can now see your blueprint references with coincidence. Once you click the blueprint references, you can select your blueprint, double-click, and open the asset inspector to see your property and values of the associated assets. You can collapse, you can sort, you can filter to see different properties. This will allow you to spend a lot less time, so you don't have to go and hunt down the blueprints in Unreal Editor. Next, macro expansion for C++. While this came from Unreal developer feedback, this is useful for all C++ developments. Unreal Engine sometimes can contain complicated macros that may be hard to memorize if you're just looking through a code. Now you can hover over to inspect and copy or expand in line. Next, we have Unreal Engine macro formatting rules. This is a special enhancement just for Unreal Engine because the way UE macros work. As you can see here, the indentation is not what you like if you're familiar with Unreal Engine projects. By going to Tools, Options, and searching for Unreal Engine, you can apply a special formatting rule for Slate Declarative Syntax and Unreal Engine macros. Now here, I can backspace, and of course, the macros will be indented like you wish. And of course, with Control-K and Control-D, you can indent them all at once. New to this year is all-in-one search. With all-in-one search, you can search your symbols and features in the same place. As you can see here, I searched for a Lyra player controller that opened up my search results as well as a code preview window. In the code preview window, you can perform simple refactoring options or navigation. But not only that, this is also a feature search for Visual Studio. You can misspell because we do support fuzzy searching. So if there's a specific Visual Studio command you forget, you can search for it. We have started building a host of code analysis tools just for Unreal Engine. First is exposing the Unreal Engine, the UHT, Unreal Header Tool warnings into Visual Studio. Upon save, let's say you made some mistakes before even compiling and seeing the errors. Visual Studio will run the UHT and put all the warnings that UHT found into Visual Studio. But we're not done. The newest code analysis is the naming convention checker. If you add a .editor config, which will provide a link at the later portion of this talk, you can give a naming rules for your Unreal Engine projects. And let's say you have cat player character. Now, with Unreal Engine, because this is an actor, Unreal Engine naming convention states that it should start with a capital A. You can click on the quick tooltip and apply your changes. Lastly, we have Unreal Engine log streaming. To open the log streaming window, you can go to View, Other Windows, and Unreal Engine log. Here, I've added a warning log that basically prints something every time a weapon is fired. I misspelled laser. Thank you, spell checker. So save, and let's compile this. Once you're in the game, you can go and test your game. Now, instead of having to keeping your Unreal Editor open or close it and lose your logs, you can now see your Unreal Engine logs in Visual Studio. Once you go to the Unreal Engine log tab, you're presented with a view similar to the output window. You can filter on processes, your different categories of logs. Here, I have a lot of extra logs. So let's filter them out. And of course, for verbosity, my log that I created was in warning, so let's only show those. Some other functionalities allow you to remove the timestamp, toggle read only, toggle word wrap, enable, disable auto scroll, clear, save, and of course, navigating your error messages. Not only can you open up with a debugger, you can also press the red record option to capture an Unreal Editor that is already in progress. So there you have it. A bunch of Unreal Engine support aimed to make your Unreal Engine development even more productive. You can do less context switching, less switching back and forth in Visual Studio. And of course, we're not done. So keep your eyes out as we continue to develop even more Unreal Engine and C++ productivity features throughout the year. As I mentioned before, here are some of the resources that you may need to get this started. For blueprint references and asset inspector, you'll need the Visual Studio integration tool, which is an Unreal Engine plugin. You can see the source code at aka.ms/vsue GitHub, which we have open sourced. Or if you're a developer who gets their Unreal Engine from as a whole from Epic Games, we have also a marketplace page where you can download the plugin. Lastly, if there are any troubleshooting, you can go to aka.ms/vsue troubleshoots to perform some basic troubleshooting steps that you might see. For the naming convention, you can go to aka.ms/ue naming convention to get a sample.editor config file. Once you have a .editor config, you can drop it into the root of your solution. Lastly, for more details, please see all of the game dev blogs that we have posted. And a quick link, aka.ms/cpp game dev blogs will take you to all of the game dev blogs we have on our C++ team blogs. So Sinem, tell us about how we can expand game development, not only from Windows, but to Linux and Mac as well.
Yeah, so a common problem that we hear from game developers is their need to target multiple platforms or utilize Linux servers to power the backend game services. So even though developers do prefer to develop on Windows and are comfortable with that and love that Visual Studio tooling, they want to make sure they're able to target multiple platforms using that same Visual Studio tooling. So some common feedback that we have received from cross-platform game developers is that they want to utilize the same debugging tools for all their different types of OS and architectures. So they don't want to spin up different types of workflows for the different OSs that they're working on. They just want to have that same no context switching mindset. Additionally, they want to ensure that their game is consistent across multiple platforms. So when they are debugging and running their game, they want to ensure that there is a visualizing element to that to ensure that everything is looking properly and working properly. Also, we have gotten some feedback from cross-platform game developers that in some scenarios, using Linux servers can be cheaper, faster, and there is no extra hardware required to that. So they want to use Linux servers to power their backend, which creates a cross-platform need. To address these common feedbacks, we recommend that you use the following tools to maximize your C++ cross-platform workflows from Windows. So first, we recommend that you use CMake as your build system. And what CMake does is it allows you to specify CMake presets for each target OS. So if you have Linux as your target OS, you can specify different presets for that, and Visual Studio will automatically dynamically update and scope based on what machine you're targeting the CMake presets that are available for that. What CMake also does is it automatically generates build scripts for specified compilers and platforms in your preset, and it is highly customizable. So if you want to add any sort of build arguments or if you want to add any sort of metadata, you're able to compile that in a CMake preset, and that will be centrally managed in your C++ repository. Now that you have CMake as your build system, you can use your target machine as Windows subsystem for Linux or WSL. What is great about WSL is that it allows you to run Linux tools from Windows without having that overhead and maintenance required with traditional Linux VMs. And it has a super simple setup. So whenever you're on Windows, you just have to run a few commands to get WSL spun up. It integrates really well into Visual Studio, so you don't have to manage a separate connection and ensure that your keys are all correct. It'll just integrate right in and be automatically detected, but also integrates into other Windows applications as well very seamlessly. WSL can be faster, more lightweight, and efficient than traditional Linux VMs as well. So it can be really great for very heavy game development. Then once you have CMake and WSL in your workflows, you can then use Visual Studio, which David showed earlier, integrates really well with Unity and Unreal Engine. So it really has that great game development background. And it also provides that really powerful debugging and cross-platform targeting. So you can use Visual Studio with CMake and WSL to have that full debugging suite. To show you the power of using Visual Studio with CMake and WSL, we have a short demo today. So what we want to answer with this demo is how can I extend Visual Studio to run my game service on Linux server while having the tools of Visual Studio, and how can I debug my remote processes? So in this example, we have a Snake game that Udacity created for their C++ course. And this can run on Linux, Mac, and Windows, and it has some library dependencies for the graphics. So what we did is we cloned this into our Visual Studio repository, and I'll show you in this demo sort of how you can have that same debugging workflow from Visual Studio. So let's take a look. So I have it cloned and I've already downloaded WSL, and it'll automatically detect that WSL machine and scope down my CMake presets based on that. So my Linux preset is shown. Then from there, I can set a breakpoint in my code, and there's all sorts of types of breakpoints that you can set. In this case, I'll set a conditional breakpoint on when the snake speed exceeds a certain threshold, but you can set all sorts of different types of conditions as well. And with the new dependent breakpoint, once that conditional breakpoint is set, I'll set another breakpoint on placing the next snake food once as a dependent breakpoint. So once that condition is met, this next breakpoint will be set. And this will apply to your Linux workflows or Mac workflows, and you can accomplish that all from Visual Studio. As you can see, as I'm scrolling, there is also that docking going on at the top, and that is a new feature called Sticky Scroll. And that allows you, when you're embedded in, very nested functions, to view where you exactly are in that function. So it can be really great for your debugging needs as well. So once WSL is targeted with my CMake preset, I'm able to press play, and you'll see that the game is running on my WSL machine, and I'm able to visualize that from Visual Studio. And once the snake speed gets fast enough, which is right here, I'm able to view the state of local variables, and the debugger is able to break on that dependent or conditional breakpoint. So that can be really useful. And now that that snake speed is at that threshold, the dependent breakpoint I set on placing the food will break the next time I have to place food. So you're able to view a lot of different things and incorporate these into your debugging workflows. But if you have this WSL machine, you may need to have an SSH integrated experience with a terminal. And so this is where the integrated terminal comes in handy in Visual Studio. What the integrated terminal allows you to do is have an SSH interactive terminal in Visual Studio, and you're able to do things like manipulate files, fire off processes, and that way you don't have to go navigate over to your terminal and manage all your SSH connections. It's all able to be accomplished within Visual Studio. So let's take a look at how that works with my snake game that I showed earlier. So to open the integrated terminal, what you'll do is you'll go to View and then Terminal. And then from here, you can select any machine you want to open up. So I'll just open up that same Ubuntu machine from before. And from here, I can fire off, for example, that same game and build that game and run any of those processes. So I'll run the commands to run CMake on it from the command line, and then make the executable. So we're able to accomplish that all from the integrated terminal, and then run the game, and you're able to see the similar output of the snake game running on the Ubuntu machine. So this can be really great for any sort of Linux workflows because you're able to interact with the terminal from within Visual Studio, and it supports I/O. So this was a pretty simple example of how you can utilize the integrated terminal, but there's a lot more you can accomplish with it as well. So without having to leave Visual Studio, what you can do with the integrated terminal is manage and enable SSH connections on your Linux machines. You can also manipulate files and run background tasks that you need to have running. You can also configure your remote system from the integrated terminal within Visual Studio. Plus, now there's a new added support for Linux consoles. So any of your Linux console apps, you can also debug from the integrated terminal, and it'll emulate an Xterm and support screen application manipulation. So this can be really great for any of your Linux workflows with the terminal. So at this point, we've walked you through how you can use Visual Studio to debug your Linux applications. But what if you have a process that's already running that you haven't had it is either in a broken state, you haven't fired from Visual Studio for any of your needs? Can I still debug from Visual Studio? So to show you that, we have attached to process, and there's other sorts of advanced debugging applications that allow you to debug from Visual Studio and debug Linux core apps under the debug dropdown. So let's take a look at how attached to process works. So I have this Snake game running that I fired off separately from Visual Studio, and it's on my WSL machine, but you can attach to really any sort of remote process that you have running. So to do attach to process, you'll go to debug and then attach to process. And from here, this pop-up will show up and you can connect to any of your machines. So for example, it'll be my Ubuntu machine from earlier, and it's going to be a WSL type. And any of these processes are available for debugging. So I'll attach that to that Snake game. And then I'll attach a GDB debugger. And so since I have this code open in Visual Studio, it'll break on the breakpoint that I set, and I'll be able to view modules, I'll be able to view symbols and local variables. So attach to process can be really great for really any process that you have running on a remote machine. And you're also able from that debug dropdown again to debug Linux core dumps, which, for example, Blizzard had used for their Diablo 4 debugging. So really exciting stuff for your complicated game development workflows. So today we walked through how to use Visual Studio to debug your remote processes, but we actually have some new exciting cross-platform tools as well that you can use for CMake and WSL that we didn't get a chance to show. So the first is the CMake debugger, which allows you to debug your CMake scripts at configure time. To learn more about how to use the CMake debugger, you can check out aka.ms/CMake debugger video. And that's a short demo on how you can debug your CMake scripts whenever they get a little complicated. And then you have the Remote File Explorer. And what's great about the Remote File Explorer is you're able to view, upload, download, and search files on your remote machines without having to navigate to a separate file manager or having to navigate to that specific machine. And to learn more about that, you can check out aka.ms/Remote File Explorer video. So what did we learn today? We learned about how you can utilize Visual Studio for all your OSs and visualize your game flows while utilizing Linux servers in CMake with the CMake and WSL integrations into VS for cross-platform debugging. So you don't have to have a different workflow. It works the way any other application would within Visual Studio. We also learned about the new dependent and conditional breakpoints. So how you can set dynamic breakpoints from Visual Studio if you want to have your code break on a specific condition or a specific dependency. We also learned about using integrated terminal in VS to SSH into your remote machines and have that interactive experience and fire off processes, which we saw with that Snake game. And lastly, we learned about attaching a VS debugger to processes running on your machines and others. So on your local machine or remote machines, you're able to attach a Visual Studio debugger too. So that functionality remains the same and you can incorporate that into your game scenarios. I'd like to thank you all for coming to our talk. We love interacting with our customers. We love responding to your feedback. And a lot of these features have come from direct engagement with customers. So if you have any sort of feedback for us, anything you'd like to see in CMake or in Visual Studio, but also across the board for C++, please reach out to us via email at visualcpp@microsoft.com. And then follow us on Twitter for any of the latest stuff that we're working on or to interact with us. So our team is at Visual C. David's is the CPP PM. And then I am CNM__Akunja. So thank you so much. And we're here to answer any questions as well.
Great, thank you so much. I have Marshmallow here who very much enjoyed your talk. We have a couple of questions in chat so far, and folks can feel free to continue dropping them in. If you want to ask any questions, please do make sure you're at the Visual Studio YouTube page. So we got a question here for David. Do the solution close C++ colorization and search performance improvements also affect CMake and Ninja projects?
The performance improvements is it will affect anything that is C++ based.
Cool. And another question is that the log filtering tool looks really useful. Would something like that be possible for other types of projects, like a plugin or something like that for non-Unreal projects?
For non-Unreal projects, please give us your thoughts in the developer community, as we're interested in hearing how a variety of features can make you more productive. So while we don't have anything planned on our roadmap for other projects or plugins, do let us know your specific scenario and the type of plugins you're working with. So let us know, and we'll do our best to prioritize according to community feedback.
Great. We don't have any more questions yet. So I just want to point out how much of a absolute fluff ball Marshmallow is. He's like that anytime I have a call or try to run a conference or anything. He wants to be the center of attention. We're about at time. We can maybe take one more question if anyone has any, or we can move on to our final talk of the day. I'm just checking that I got my times right. Oh no, we got 5 more minutes, so we're okay. So any more questions, let us know. I'm interested, the CMake debugger stuff, we upstreamed that, right? So what does that look like? Like what can folks from across the industry use?
Yeah, so our work has been committed upstream very recently, I think, as of last week. So you're able to fork that then and develop your own sort of CMake debuggers or any sort of features that you want to add to the functionality, which is really exciting. And for example, we'll look to then use that forked repo for VS Code CMake debugging. So I think it'll be a lot more accessible and it'll be developed on a lot better. So I think there's a lot of exciting stuff coming from that upstream contribution.
Yeah, it's very cool. And yeah, it's something that I've always wanted when debugging obscure CMake issues.
Yeah, I think it, again, a lot of customer feedback was, we want to take a look into this CMake language and be able to step through it. And I think that it's really great in that regard. So I'm very excited about it as well and hope anyone using CMake is able to use it. So.
All right. Well, it looks like we don't have any more questions. So thank you very much for your talk and your time. And we will move on to the last talk of the day. So next up, Gabriel Dos Reis is going to tell us about build time reflection with C++ in the year 2023. Hey, Gabby, welcome. Thank you for coming once again. Have you given a talk every year so far? I think you have.
Yeah, I'm happy to do it. I'm passionate about
a veteran
and modules, and anytime.
Great. Well, take it away.
Okay, so as you know, I've been talking about modules since 2015. And back then, I've been busy telling everybody, "Oh, modules are great. Modules are tooling opportunity, and that kind of stuff." So today, I wanted to briefly tell you some of the awesome things that you can do with modules, not just because your code looks better, but what you can do with, let's say, a leftover of modules. Not really leftover, but build artifact. When you build your modules, the compiler generates a bunch of satellite files, information that it uses to process the rest of the program. And that build artifact is not just good for the compiler, it can actually be good for you. And one of the things you can do with it is to have your own reflection. I know that in the C++ community, we have been wanting to have static reflection for a while now, and it might probably take another couple of years or more before we get it. But in between now and then, what can you do? So here I wanted to tell you, you can do a lot of stuff that don't actually need an upgraded compiler. So a reflection, the notion of reflection is just the ability of a program to examine, query, introspect, and not just that, but also manipulate its own states and structures and behavior based on the questions that it asks itself. And that's quite fairly general and to some degree abstract. But when you look at that definition, you have the notion of, introspection, which is just really query, not modifying anything at all. And indeed, introspection is just that part of reflection. And some people will tell you, oh no, introspection is not reflection. But it usually is easier to implement. We already have that in C++, and of course you have it in other languages, but in C++, for example, you have runtime type information. When you use type ID on an expression or a type, the compiler creates a data structure that it embeds in your program, and then at runtime you can query the type and a bunch of other stuff. It's something that's quite nice and allows expression of certain ideas. That's quite easy to do, as long as it is well supported. When it's not well supported, that's where you get a bunch of stuff. So the general idea of reflection, introspection, they are notions that can be practiced at any stage of the development of a program, whether it is during pre-processing stage. You know that you can use the string signification operator from the macro preprocessor to get the string of a name, right? And you can do concatenation, so you can actually build more names, more stuff. And in program, you can use trait. We've been using trait since C++ 11. You can query states of a type or an expression, an object. Decl type is one of those introspection operator. Same is no except. Would an expression raise an exception, for example? So those are properties of expression. And then, of course, you have runtime behavior. If you perform a dynamic cast, for example, that's during program execution, and the compiler is required to generate data that embeds your program in executable, and at runtime it carries some operations to try to find the right type that you're casting to. And people will tell you, well, reflection is great, but it's not free. It costs stuff. Like compiler really has to embed something in your program, and that can be gigabytes. So sometimes people say, yeah, reflection is great, but I'm not ready to pay the price for the additional object size increase that I'll get at runtime. On the other hand, like I said, we have been waiting for some notion of static reflection for a very long time, and some people are tired. We have systems deployed that have their own meta protocol. If you know the Qt GUI system framework, for example, you know that it has the mock compiler, that meta object compiler that look at your program and then generate supporting infrastructure to make sure that your slot and signals are connected and everything is working properly. That's just one example. So if it has been taking that long to do, how hard is it really? It's a type, just associated value. How can that be? The truth of the matter is that if we just look at introspection, for example, runtime introspection, we have runtime RTTI, for example, or exceptions. You can think of them as some kind of continuation where you have program point, say program point that you want to jump back to later, and then you turn that to data that you manipulate. Well, one of the things that does is it hinders optimizations, right? The compiler can't reason saying, oh, this thing exists there, I know the structure and I can come back to it. Well, nobody's going to come back to it. I can right away inline it or move codes around and so forth. So it costs. And furthermore, one of the debates in the C++ community is whether you should ever enable exceptions or RTGI at all, like TAP-ID, because it makes your program bigger. Yeah, so we know we have evidence that a poor implementation of these facilities can actually be detrimental to actual adoption. And it takes time and effort to implement these things properly. So it's non-trivial investment to make. Now, when you're talking about reflection, so remember, introspection is just ability to query, observing without changing the state. But reflection, you not only doing query, but you also want to modify the behavior of the program or generate new stuff based on what's new. Well, it's an order of magnitude at least much more difficult, in terms of deployment, implementations, and so forth. And once you have a reasonably good reflection system in place, it becomes much harder to evolve the language, because, well, some of the construct that you knew when the program was compiled, they were turned into data embedded. And if later you embed it in your executable, if later somehow you bring in component that was compiled in the future or in the past, and they do not agree on the protocol, well, you get into real trouble. So once you have reflection in there and features or functionalities that are reflected become much harder to evolve properly. So that leads to people to say, well, we don't really want runtime reflection because we know it makes the executable much bigger and it has a bunch of other stuff. Well, we just want static reflection, which just means that during compilation, we know the state compiler already has those information as its own data structure. We just want to be able to poke a little bit and then ask the compiler to generate a little bit more code, but based on what is known at the time of compilation. So the evolution problem is a little probably more reduced, but you still have substantial work to do on a compiler. So we know compiler writers, C++ compiler writers, we can fit them in a room. And then we have millions of C++ programmers. So if you can just get a couple of people suffer for the greater good of everybody else, so be it. So that's good. And having static reflection, mitigates, many of the drawbacks that I mentioned earlier, including performance and space, which is part of why the standards committee and the community as a whole have been pushing for this notion. I am here to talk about build time reflection and not static reflection. And some people will rightfully say, what the hell is this thing that I'm talking about? Well, it is not a new language feature. It is not. What it is just just being, very responsible with the resources that we have. So the idea is that as we're building the program, during build time, we generate build artifacts, and we would like to be able to augment the program, the final program, with information that we know during build time, so we can generate new code that gets compiled and linked with the rest of the object file that already exists to create the final program. So it's really involves build time code generation, and it moves the burden from the compiler to the programmer. So, if you're interested in reflection, one of the questions that you should ask yourself is, how much of the work that I'm asking compiler writers to do can I take on myself? And how much of that can I get the community, help develop? And that is what, this is about. What can you do based on what is known during build time? And so the way, if you want to do build time reflection, you have to structure your program build in a certain way. You start with already known source code. It could be human authored or machine generated, and then you compile those things, and then let's say, for example, you have module interface source file. When you compile it, you get what we call build module interface, or BMI. Or if you're using MSVC, we'll say you have an IFC file. Well, that build artifact contains a lot of the semantics information that compiler knows. And it is possible for you as a programmer to go and crack open it and then generate new C++ source code that can now get fed into the pipeline of the build pipeline to augment your program. And you do this, iterate this process as long as you need till you don't need to generate more stuff. And then when you link everything together, you get a system that is fairly powerful. It doesn't give you everything that static reflection will give you, but my hypothesis and conjecture is that it gives you nearly about 90% of what we have been waiting for. So it's a good thing to invest in. For this to be successful, you have to be mindful that because you're generating code, your build system out to support, automatically generated code. Most build systems support that. And if somehow you're still writing your own build definition by hand, maybe this is the time to reconsider your choices and see if something else can help you there. Okay, and another way of looking at build time reflection is it's some form of grain computing. Like you imagine you're using all these things, and then something was generated as a necessity, and you're not leaving it go to waste. You're reusing that information, the same information that the compiler had before. You too can have that. And with modules, it's there anyway. Like, it's not additional work that we are asking the compiler. The compiler already did that work. So we're just being very responsible with the resources that we have. So now I want to just illustrate the idea of build time reflection by using a very, very simplified example. The idea is not so much that I want to trivialize the problem. It is to convey the basic of the idea. Once you get it, I trust you that you'll take it and run away with it and make it as complicated as you want. That I trust you with. So I'm just going to use a very, very simple example. So don't discount the example. Just think of it as just a way of doing something. It's a template, and you can use it and magnify it, instantiate it in other situations. So the example that I want to look at is, imagine that you have a program, you're writing a program that has a bunch of types, and somehow you need to do a lot of formatting, IO formatting, because you're sending data, you're doing distributed computation, you're sending data over network, or you're saving data on file and then reading it back later. Imagine you're doing game development and you want to save some characteristic of characters in your game, or skinning and so forth. Well, how do you do that kind of IO thing automatically, so that you don't spend your time. You spend your time actually programming a game as opposed to doing work that is best left to machine. So the example I'm going to give you is using, of course, modules. And what I use? So for this to work properly and to scale, we can't just go through the entire program and then generate IO formatting function for every single type that we find in the source file. That just doesn't make any sense. I don't know if it will compile, and if it does, it will just be waste. So we need an ability to annotate in this source program, hey, I need something to be done automatically for this type. Okay, so we need a hint, whatever it is. If you were designing a new programming language, we probably need a keyword or something. But remember, I'm not here to talk about a new language feature. I'm here to tell you what you can do with the existing language. When I say existing language, I'm mostly thinking about C++20, C++23, which should be out very soon. And you already have compilers out there supporting most of C++23. So the ability to selectively tell the tool, the system, to generate certain code for something will help reduce code bloat. And by doing so, we'll also improve efficiency, overall efficiency. You know that space is time. If your binary is big, it's probably going to eat up a lot of space, cache lines, and so forth. So take this very simple example. Imagine I'm dealing with points in planar geometry, and I have a struct point. And the usual thing, have a coordinate, x and y. Of course, I will go and write my own formatting function, but it's boring. It's boilerplate. We want to increase your productivity. We want you to delegate that boring aspect to a tool. Just define your abstractions and we'll take care of the rest. That's what reflection is really good at. So in the example that I'm showing here, like I said earlier, we need a way to annotate. So here I'm just using an attribute on the type definition here. Now struct point to D, have this attribute say GDR generates output. So this is just some kind of DSL for me to tell the tool to generate IO functions for this type. I don't want to write that function. I want the tool to write it for me. And what will happen when I do that is something like the following. The tool, this tool that helps me use real-time reflection, will generate a new module source file. It will take the inputs module here, so plane.geometry, and it was that name, and then as basis, and then we'll add reflected.output. Usually when you have tools, it's good if they can predictably name things, right? And then the next thing it does, all this is generated source code. I say import stud. Remember, with C++23, now you just say import stud, and then you move on, do whatever you need to do. And you can use this thing today. Like import stud works today if you download the MSVC compiler and using either MSBuild or using CMake, it will take care of all of that. And then the next thing it does, the tool does, is generate this function, operator less than, takes an IO stream and point to D, and then formats the coordinates of the point in a stylized way. And if you look at the code carefully, those places that are green text, you'll know that they're entirely determined by the structure of the class, the struct that's here. The name members, and that's all. So it is purely mechanical, and this is something that a tool should do for you. You do not need to do it. The fact that the base language does not have this facility built in is a shame, but it's okay. We can get the tools, take care of those things that can have here. So like I said, this is just a simple example, but imagine you do not want a formatting like this. You want, let's say, in JSON format. So you'll have your tool generate the codes, using JSON library. Or if you want to have a banner representation on disk, or you want to send over to network, all those things, they are boilerplate that have structures, like they are templates that can be done automatically for you. And the only thing that so this is a source code that's generated by the tool, and I have to make sure that my build system knows that this source file is going to be generated by the tool so that it schedules its build properly. The other thing that I, as a programmer, need to do is just to write my main program that's using this thing. So plain geometry, that module is something that I authored. That was input into the tool. Then the tool will generate automatically for me this other module, plain geometry reflected output. That now I can just import stud again, and I can just use the insertion the formatting operator that was automatically generated based on the structure of the class that was defined. So this is a concrete example. It is simple, I agree, but what I'm trying to convey here is not how sophisticated it is, but how simple things can be. Okay, and most of your complicated situations where you want to have static reflection, you can structure the code in a way that you can actually use build system by carefully putting and design the interface so that you can have this cycle that I mentioned earlier, how you orchestrate the build. So the summary. Of course, the IOStream example is simple, but it is a template. Again, it's a template you can use. You can generate JSON, YAML. If you're doing gaming stuff is where you have a lot of need for reflection stuff, because you have types that you define in your source code, but they represent stuff that you want to, associate properties with, and in a way that is mechanical. So you can actually have the tool do these things for you. These functions that are doing the output function, they are automatically generated, so they are always up to date with respect to the type definition that is in your program, right? So you don't have to worry about it. And also, if you happen to change a field or something, you don't need to go and hunt 25 places to try to change those things. The tool can just automatically generate everything for you. And you can deploy this today. We do not need to wait for 2, 3, or 5 years, or decades to get reflection in the code, because this is simple enough that it can be taken care of. And you can have your own, like if this doesn't work for you, you can have your own generator based on the logic and the needs that you have. That's the beauty of it. You do not need to go and extend the compiler. You just need the compiler to tell you, hey, while I was building that module, this is what I found. Is that useful to you? And say, oh yeah, great. Give that to me. I know how to use it. Okay. So all of that is kind of very high level description of how the code is generated. When you're using the MSVC compiler and you build a module, it generates an IFC file, what we call builds module interface in standard terminology. The MSVC format, the IFC format, is publicly documented. As a matter of fact, we want the community to really use it, extend it, and however they see fit. A couple of years ago, I gave a presentation about how you can actually decompose an IFC file, and in another talk that's interesting that for you to see is one given by my colleague Cameron De Camera, in the way he showed a viewer of an IFC file written entirely in JavaScript. So it's not even C++, right? So when we say modules that are tooling opportunity, your tool doesn't need to be written in C++. It can be in any language you want, as long as you can read a binary file. Okay. The last thing I wanted you to know before I go out is, please start using modules today, especially with C++ 23, where you don't need to remember which header file you need to include, this and that. No, just say imports to, done, boom. And furthermore, it is much faster. The build time is improved because the stud module, it's built once, it's reused many times, so the compiler doesn't need to reparse all the time. It is simpler to use as PCH. If you're on PCH today, I really invite you to start considering using modules. And if named modules are a bit too steep a step for you, probably start with header unit. But really, what a game is not named modules. There is to be a GitHub repo that contains all the source code that can use as inspiration that demonstrate what I just talked about. And please clone it, extend it, use it any way you want. And give me feedback. Well, what else would you like to see? Would you want an SDK? How? What are you going to do with it? Let me know. And finally, the IFC spec is there on GitHub as well. It's for the community to evolve, contribute, and give feedback. With that said, I'm ready to take questions.
Thank you so much. So we've got a few questions in chat. We have one from Antonio, which says, "Reflection is a fish hard to sell. Why not show some code?" You showed some code. This was from about halfway through. What arguments do you have on what there is to gain by using reflection? What are the use cases for reflection in C++?
Oh, okay. Yeah. So not everybody needs reflection. But the first thing I have to admit now, clear, not everybody needs reflection. In the talk, I gave the example of formatting. That's just, every time you're doing IO, many of these types, they have a full certain pattern and they're very repetitive, and you can get that automated. If you're doing gaming, you have types, the characters in your game, they tend to have properties, values associated with them, and you can have that saved on disk and read back automatically. Again, the way you do that is very repetitive, very structural, and best done by tools. If you're doing distributed computation, these days we talk a lot about AI. Well, AI is very compute intensive, and when you're doing the work, the best way you do it is you distribute the work. So you have to send data over network. How do you get that done properly? And making sure that the data you're sending, the structure, everything is in sync. Best use, reflection to take care of that for you. So it's not so much reflection in itself. It's a tool to take care of boilerplate so that you can focus on the most creative aspects, the joyful part of programming.
Thanks. And then we've got a few questions from Milos, who says, do we believe static reflection would allow us to finally get rid of macros, or are we cursed with hashif defined _ clang for the rest of time?
Well, okay. So modules take care of a good chunk of the macros. So the if dev, that kind of stuff, taken care of by modules. Now, when we're talking about compiler-specific characteristics, like certain features are available only on Clang or GCC or MSVC, those will still be there. But when we're talking about code generation, one of the things I don't like macros, but I also have to confess I use macros as a way to generate codes, like generate sequence of tokens that are compiled by the compiler. Well, my sincere hope is that we will get a good static reflection system that will take care of that huge swath of need for code generation. Then what is left is probably unstructured code. Sometimes you just want to include some text. It has no structure to it. Well, you still have to use, macros for that. But having something that plays by the language rules that your IDE understand, your build system understand, is much better than having this, character string manipulators.
Yeah, for sure. And the reflection repo, you're going to push that live after the talk, right?
Yes, yeah.
Cool. Another question is more theoretical, but do we think it would be smart to have a pre-build step that is going to do this generation so that the IDE knows that these things exist?
Yes, I agree. Yes, yeah. That's actually a good point. We talk a lot about what reflections. They're great, but they also add complications to the IDE experience, where certain functions that now available at compile time or invoked at compile time need to be understood by the IDE in order to provide better experience. Yeah, absolutely.
And then another more general one for everyone. Any good introduction to compiler development? On that one, I'd recommend the book Crafting Interpreters.
Yes, absolutely.
It's about interpreters, but it's mostly all applicable to compilers as well. You can read that book and then pick up something a little bit more, delving deeper into compilation techniques like engineering a compiler or modern compiler development in ML or C or Java, whichever one you like for some of the more compilery things. But Crafting Interpreters is just such a well-written and structured book that I recommend.
I 100% agree. And if anybody, you should take Sai's advice on it. This is great. And if you do it, you'll find out that if you're writing an interpreter, and you want to do, let's say, IO, for example, because you need to read you'll find out that you need a way to reflect the facilities in the C headers, on the C++ headers in your interpreter. And this is another place where actually reflection help you write simply your interpreter. That's fantastic.
Okay. Second cat of the day here. Actually, her name is Lexical Analysis Cat. So
lexical analysis and
very
marshmallow.
Okay. Yeah. Anchor asks, what compilers does?
It's a question about GCC. Oh, okay. My apologies. The only reason I didn't mention, so I think on the last slide I said that use modules today. You have CMake build system support. And they have build system support for MSVC and Clang. It comes in box. For GCC, it's not because it's more like the necessary support is not there yet, so I didn't want to lead people on something. But it should also be mentioned that GCC also has support for modules.
Okay, and then there's one more on what compilers does GDR generate work with?
Oh, so all the examples are built with MSVC. So the IFC format right now is very specific to the MSVC compiler. I use my private, network private build to do that. So whatever preview is there as of today will work. I would like to see the community coalesce around a common format for module interface, whether it's IFC or something else, doesn't really matter. But being able to have these tools work, cross-platform, cross-compilers is fundamental for us, the C++ community, to realize the promise of modules being tooling opportunity.
Yeah, and I think that answers the next question as well, which is, could this work be implemented for other compilers like GCC and Clang?
Yeah, so the IFC spec is public, and if someone feels energetic enough to to get a fork and generate IFC out of it, it will work. If you do that, you do not need to change GCC's own internal representation. You do not need to do that. That's going to be a huge amount of work. No, what you will need to do is just ability to translate the IFC data structures into GCC's or Clank's internal representation. I think if I were to do that, that's the way I would do it. I will not sign up for, we need to rewrite GCC or Clank using IFC. No. Just ability to read or write. That's it.
Yeah. And then still got time. So another question is, could the IFC spec be put in the C++ standard?
Probably not C++ 26 or C++ 29. Of course, I would love that. But the reality of things is that for something like the IFC, you need it to evolve as quickly as possible, the way compilers evolve, whereas the standards tend to be on 3 or 6 years roll. So if it could just be some kind of de facto standard, I think that will take care of all the practical needs that we have and then let it evolve as quickly as it can. And I would really love to see something like that happen.
Great. Well, we are out of questions and almost exactly on time. We stayed on time for the entire thing. Kind of
Thank
suspicious.
you. You're running this thing quite well.
Yeah, it's our 4th year. We're getting the hang of it.
Yeah.
So thank you very much, Gabby. Thank you
Yeah.
for everyone who has stuck around and watched all the talks. These will be put online on the Visual Studio YouTube channel. So please keep your eye out for those going live, and feel free to share them around if you have enjoyed. So thanks very much, and hope to see you all next year.